Hopefully you guys are geared up for this lesson of 6-4 rational exponents. Basically, rational exponents are another way of working with square roots, cube roots, fourth roots, fifth roots, anything like that. So basically, we're going to kind of use rational exponents now with fractions, right? Rational means fractions, so exponents have some fractions, and I know we love some fractions. Well, let's kind of get right down to the nitty gritty. Hopefully, this video is not too long. I apologize for the last one again. I can only do it so many times, but let's hopefully see this one's hopefully not that bad. So first, write each expression in radical form. Well, there's something we need to know. We need to know that if I have a square root of some variable, say x, okay, I can rewrite this as x, and then the 1 is really the exponent on that, and it's to the 1/2 power. So this is k to the 1/2, and I want to write this in radical form. So what happens is my denominator becomes the index of the actual root. So if since this is a 2, it's now the square root of k to the 1st power. Okay, so k to the 1st, square root of it, I can rewrite it as an exponent. Exponents, rational exponents, and square roots, cube roots, all that stuff, they go together. So it's basically the same thing, just another way to write it. Now, again, we look at the denominator here, 3. That's now the 3rd root of what? M to the 5th power. Okay, so that would be our answer. So when it says write each expression in radical form, that's all I want right there. Now we're going to go backwards. It says write each expression in exponential. That means that I want to have some value raised to a power. Okay, so what I'm doing here is I'm going to take the number that's inside, 10n, and you see that it's all inside and it's all being raised, okay, like the parentheses around all of it. So I'm still going to have the parentheses around all of it. The 2 here is going to be my numerator, and then the 3 is my denominator, just like it was up here. That's the denominator, and then that's 3 is the denominator there. And then number 4, I'm going to take 3p and put it in parentheses to the 3/5. If you don't put this in parentheses, it's going to look like this. And right here, it looks like the p is only raised to the 3/5 power. But in the problem, everything is raised to the 3/5 power. That's why you put parentheses around it. No parentheses means it's wrong. Okay, number 5 and 6, I want to simplify. What does that mean? That means that I want to actually find out the value of what is there. Okay, so here's how we're going to do this. What's going to happen is it's x to the 15th times 2/5. Okay, this is from back in junior high. We did exponential rules, and we'll have some more practice as well. But what I do is I take 15 times 2/5. So if you do it on a calculator, you're going to take 15, right? You're going to do multiplication, parentheses, 2 divided by 5, and you should get, I believe you should get 6. So that's x to the 6th power. Then 32 is also being raised to the 2/5 power. So you're going to do on your calculator, 32. How do we raise it? What button do we use? We use the exponent, the up arrow, right? It's called a caret. Parentheses, 2/5. Okay, and I should get 4, and that's 4. So then I get 4x to the 6th power. That's my answer there. Okay. Number 6, 64n to the 6 to the 1/2. So I'm basically taking 1/2, if we remember from up here, this is actually square root. Okay, 1/2 is the square root. So what's the square root of 64? That's 8. And then n to the 6th multiplied by 1/2, right? That's 3. So n to the 3rd power. Okay, there's some questions there underneath the you try. I want you guys to work on those now. You got to take about, I don't know, a minute or so to work on those, as much time as you need, and then hit play. Okay, number 7 here, you try. I want to put this in radical form, so I want some root there. What's the root? What's the index? It's a 6. Remember, denominator goes with the root. And then I have 2a inside, and all of this is being to the raised to the 5th power. There's multiple ways you can write this. This is one of them. I could also write it this way as well, 2a, and I can put all of it in parentheses that way. Those are the only ways you can write them. Basically, they're the same thing, so either one of those is fine. If you do not use parentheses, you will be wrong. Number 8, 4th root, because that's my denominator, and then 5a, and then I can put parentheses around the whole thing, or I can say, okay, hey, the 4th root of 5a, parentheses around that, and then, the 3rd root, or the 3rd power on the inside, right? This is an exponential, so this is going to be x to the, 8/5. I do not have to use parentheses around this one, because it's only one individual term. If you notice in number 10, you have two terms. You have the 10m being raised to the 4/3, okay? So that's your answer there. Simplify. 81 b to the 4th to the 3/2. All right, so again, you can put this on your calculator. 81 caret parentheses 3 divided by 2, and I believe you get 729 if I can do my math correctly in my head. And then b to the 4th to the 3/2. You again take 4, you times it by the 3/2. Its exponents are multiplied, okay, but then the number is being raised, so that's why there's a caret here, not a multiplication. So that's, I get 4, I'm sorry, I get 6 again, right? So n to the 6th power, there we go. That's our answer there. Number 12, 81 to the 3/4, so 81 caret 3/4 should be 27, and then n to the 8th times 3/4, and I get 6 as well. I get another 6, I got a lot of 6s here. What I want you guys to do in the next couple problems, it's in the remember section. Remember. Hopefully we do remember. What I want you guys to do is look at those problems there. I want you to try as much as you can. Hit pause, try them, hit play. Even if you don't know how to do them, I don't care. Just look at them. Man, it might come back. It might be like, oh, I kind of remember, but I don't. I don't know. We're going to find out. All right, so just hit pause real quick, and then hit play, and then we'll discuss them. All right, remember, so this is basically, in all seriousness, this is from junior high, okay, or middle school, depending upon where you went to a school, but because this is an 8th grade standard, okay, this is an 8th grade standard. Now, some of them you might be like, well, these are pretty hard. Like number 4 is kind of difficult. I would agree, but it is an 8th grade standard. And you probably did this also in Algebra 1 as well as a freshman or 8th grader, depending upon when you took Algebra 1, 7th grader maybe, depending upon, again. So let's kind of go through these. I want to get away. I want to. I don't know the rest of the words. 2 times 3 times 3, multiply them together. That's 9 times 2 is 18. And then I'm going to add the exponents. A plus, no more a, so it's a squared. And then for b's, I get -3 plus 1, that's b to the -1. But your answer should contain only positive exponents. Well, that's a negative. Hopefully you remember that a negative exponent, what happens to it is it shifts to the bottom. So it's 18a squared over b to the 1. Or just b. You don't even need to write that 1. Now, again, we'll have more practice on these, so if you forget how to do them, that's okay. And the next page, you'll actually see that there's some rules there that we'll go through. And these are the rules that we're going to go through as kind of a quick refresher. Number 2 here, I'm going to take this, and because it's a negative already, I'm going to put that in all my denominators. So it's 3a squared b to the -4 to the -4. There we go. And then all of that is being raised to the 2 power. Now, you might be like, well, why doesn't the -4 actually flip? Because I put it in the bottom. Well, really, the -2 is the only one I'm dealing with right now. And now let's kind of multiply them out. So 3 squared is 9, so I get a 9 here. Multiply powers, 2 times 2 is 4, so it's a to the 4. B to the -4 to the 2 is what? B to the -8. But because that's a negative, it goes up top, so it's really b to the 8. Over 9a to the 4, right? So b to the 8 over 9a to the 4. That is my answer for number 2. Number 3, reduce if I can. 4 over 1, I cannot do that. So it's 4. X to the -4 over x to the -3. Since they're both negative, I'm going to flip them. So it's x to the 3 and then x to the 4 on the bottom. I flipped them, and then y to the 3 is still there. And then the 4 is also up there as well. So now, I have 3 here, I have 4 here, so that cancels. Now I have, oh, sorry, just a 1 there, duh. So I get 4y to the 3 over a single x, there we go. Number 4, this one looks crazy. Wow, this is going to be all long, so let's erase, let's do some erasing here. All right, here we go, 2. So I'm going to multiply powers. So this is really a 1 here, right? So it's 1 times 3, so it's 2 to the 3rd power. I get h to the -9 power. I get k to the -9 power. Times, now again, this is a 1, that's a 1 as well in the j. So that's 2 to the 2. I get j to the 2, k to the 4, over, and now this, I don't actually have to move anything there, like multiply with powers and stuff. So what I'm going to do is, this is just a single 2, okay? So now with my k, I have a single k here and a 3 k's there, so that means I have 4 of them, right? I add them. and then h to the negative 4, and then an h to the 1. Remember, I add them as well, so that's h to the negative 3. J to the negative 3 and j to the 2. Again, I add them, and I get j to the negative 1. Now, what I'm going to do is I am going to move my negatives on top and on the bottom. So if I have a negative on top, I'm going to put it on the bottom. If I got negatives on the bottom, I'm going to throw them on top and then combine what I can. So if I look, 2 to the 3rd, which is really 8, 2 times 2 times 2 is 8. 2 to the 4 is, or sorry, 2 to the 2 is 4, and then those multiplied together make a 32. And then I'm going to now move my h's and k's and j's and all that stuff if I have to. So let's do that. This h to the negative 9 goes to the bottom, so now it becomes a positive 9. Oh, I do have a 2 in the bottom, right? So there's 2 there. So I moved this. That's good. What else do I got? I got k to the negative 9. That goes to the bottom as a positive. What else? J's in these k's stay, so that's j squared k to the 4. And then what happens? K to the 4 is still on the bottom as well. H to the negative 3 goes to the top. J to the 1 up to the top. And now let's do some canceling here. I have a j to the 2 and a j to the 1 on top, so that becomes j to the 3 because I add them. 32 divided by 2 is 16, so that's also up on top. K to the 4 and k to the 4, those can already cancel because they're exactly the same, so that means what? I have a k to the 9 on the bottom. And then h's, I have 3 on top, 9 on the bottom, so that means I have 6 more left on the bottom. So that is your final answer. All of that work from this whole original problem boiled down to this one right there, right there. Okay, now let's get to the second page. There's a whole bunch of rules on the second page that you're going to have to write down. I'm going to have them written down already, and then we'll talk about them. So you'll just write them down when you see them. All right, guys, here is the rules that we're going to be dealing with. Now, there's a whole bunch of writing there, but I want you guys to pause the video and finish writing those out. And then what I'm going to do in the third column there is I'm going to go through some examples. Okay, so again, pause the video now and then write these down and then hit play. All right, multiplication rule. Basically, the multiplication rule is saying that if I have variables that are the same, like the bases, the a values. So for instance, I'm going to give you a couple examples here. So if I have x squared times x to the 4th power, the rule says that since the a's are the same, or the x's in this case are the same, that I take the exponents m and n and I add them. So that's really 2 plus 4, right? I add them up here and I get 6. So the same thing goes with numbers as well. So if I have 2 to the 3rd power times 2 to the 6th power, if I add those up, I get 2 to the 9th power. Okay, and then you can do this on your calculator or whatever that is. But that's what you're doing, right? You're adding the actual exponents because you're multiplying, you add. Power to a power basically states that if I have any single variable or any number, right, and raised to a power already, and then I'm raising it to another power, the rule says that I take the powers and I multiply them together. So that's actually x to the 6th power because 3 times 2 is 6. Basically, think of this power to a power and the product to a power as the distributive property of exponents because the 3 is being multiplied by that 2. Just like with distributive property. Same thing down here. This is anything here. So this is, say, 2 to the 2 power and then x to the 7th power, and I'm raising that to the 6th power. The product to a power states that I multiply powers together. So this is really 2 to the 12th power and x to the 42nd power. Okay? So that's what it's saying. You take it and multiply them together. You distribute it through the parentheses. Negative exponents basically states that if I have any variable raised to a negative power, in order to make the power positive, I have to flip it. So x to this, if it's x to the negative 7, in order to make it positive, I have to put it to the denominator. But if it's already in the denominator, in order to make that positive, I have to flip that, and now it's in my numerator. So x to the 8 is in my numerator now. Okay, so wherever it is, if it's in the denominator, you flip it, now it goes on top. If it's already on top, you flip it, goes to the bottom. That's what a negative exponent does. So quotient rule basically states that if I have a variable to any power, so let's say x to the 4th, and I'm dividing it by, say, x squared, what you can do is you can actually take the top minus the bottom. So x to the 4 minus the 2, which is x to the 2 power. Now the question comes is, where do I know where my answer goes? So for instance, I'm talking about this. If I have x to the 3rd power over x to the 7th, When I subtract those, I get x to the what? Negative 4 power. So you get a negative, but this is on top. Well, again, negative exponent says it actually goes to the bottom. So the answer would be 1 over x to the 4. And another way you can think of it is this. Where do you have the most variables? I have the most variables up top here. That's why my answer stays up top. In this particular example, I have the most variables in the denominator. That's why they go to the bottom. That's why my answer is in the bottom. Okay, quotient to a power basically is, again, a distributive property with your dividing quotients and all that stuff. So if I take any variable to any exponent, divide by some other variable to another exponent, and it's to another power, say 4, basically I'm distributing this through and to here as well. So it's x to the 8, again, multiplying 2 times 4 is 8, and then 3 times 4 is 12. So that would be your quotient to a power. Combined like terms, that's something we've been doing, right? If you have x squared plus 3x squared, and I get 4x squared. But if I have x to the 3rd power plus x to the 2 power, I cannot add those together. That is my, I guess, combinable answer, right? I can't add them because the exponents are not the same. So the exponents have to be the same. But what do you notice when I add, the exponent stays the same? Okay, so this is 2, that's a 2, and then in your answer you also get a 2. The only thing that changes are the coefficients. Okay, we're going to be using all of those rules to now continue working on this particular section. You're going to make sure you have to have your graphing calculator or some calculator that does fractions. It doesn't have to be the graphing one. They don't actually work as good as the scientific TI-34s and stuff. But if you want to use graphing, you can. I'm going to use the graphing to show you kind of how to do it. So let's keep going. Now, you notice it says harder, like I can't just, sugarcoat it here. These are going to be a little harder. I'm going to try to start you off a little easy and then kind of get it really hard for you. Your answer should only contain positive exponents. That is a given. Always has to be positive exponents. Okay, and let's go through it here. So 13. Again, I'm multiplying here, so I want to add exponents if I can, if they're the same variables. So 2 times 1 is 2. Y's, I have 2 and 2 of them, so that gives me 4 of them. And then I have my z to the negative 2, but it's negative, so I got to flip it. So my answer is 2y to the 4 over z to the 2 power. And again, you notice my z's have a little line through them. That's to distinguish them from a 2. So please make sure your 2's and z's are different. Number 14. Now we got some variables with some exponents that are rational, some fractions. I know we love fractions. Well, let's get through them here. 4 times 2 is 8. Z's, I have a z here, which is 1, and then I have a z, which is 5/3. So you really have z to the 1 plus the 5/3, right? And again, your calculator can do that, and it's going to be 8/3, which is what it's going to be. If you type in 1 plus 5/3, it's going to give you some fractional decimals probably, but it's 8 over 3 is what it should be. Then I have x. What do I have? I have x to the negative 2/3, and then plus 7/4 here. So negative 2/3 plus 7/4. I'll pull up my calculator and I'll show you how to do that here in a little bit. And then y. What do I have for my y's? I have negative 4/3, and then I have another y is negative 3/2. So minus 3/2. Okay, so now let's pull up my calculator and see what I can do. All right, here's my calculator, and you notice I already did the z's over here. 1 plus 5/3 is 8/3. But if you don't remember how to do that, so here's on this calculator, I'll show you how to do that. You're literally going to do 1 plus, and then you have to put parentheses around your fraction. So 1 plus 5/3 will give me some decimal value. But if I hit the math button and then hit the fraction, okay, the first one there, that's going to give me that answer as a fraction, which would be 8/3. So that's what I already had there. So now I'm going to do the same thing for the rest. So I want you to, again, make sure you can do this. I'm just going to do it real quick, and then I'm going to get the answers. So that's what I get when I do my x's and y's. I get 13/12 and negative 17/6. But what do I know because of the y is negative? It actually has to go to the bottom. So I get 8z to the 8/3, right? 8z to the 8/3, x to the 13/12 over y to the 17/6. Okay, so that would be my answer for number 14 right there. Okay, that's pretty much as hard as they're going to get. We might have some parentheses and stuff like that, but that's pretty much as bad as they're going to get. All right, let's keep moving here. All right, number 15, I got 2 and I got a 1 here, so that becomes a 2 and I multiply. My p's, I have -5/3, so p to the -5/3. And what am I doing? I am subtracting 7/4, or I'm adding a -7/4. So p minus all that right there. And then what do I got? I got q's as well, and I got 1/4. So q to the 1/4 minus 1/2. And then my m is just the squared, so that's an easy one. So again, calculator comes up, and I should be able to calculate all this stuff here. So that is what I get there. I get 2p to the -41/12 when you do that calculation on a calculator, haha. And then q to the -1/4, again, 1/4 minus 1/2 is -1/4. And then m squared is the only positive value, so everything else goes in my denominator. Now you notice some of you might want to put the 2 in your denominator. It's not a negative. The actual exponent is a +1, so that's why it stays up top. Okay, so I get 2m squared up top, p to the 41/12 times q to the 1/4. 1/4. Sorry, I don't know why that does it all the time. So 1/4. That's your answer right there for number 15. Let's go on to 16. Okay, this one shouldn't be that bad. 4 times 4 is 16, right? 4 times 4 always is that, 6, hopefully. M to the first plus m to the first, which is m to the 2, right? 1 plus 1 is 2. N squared, or n to the -2, I'm sorry, n to the -2 minus 5/4. We'll have to do that on our calculator. There we go there. And then p to the 1/2 plus 1. That's what a 1 is right there. So there we go there. Now let's use a calculator. Again, you should be pausing and going from there. And then let's see what we get. So when I do the calculator, this is what I get. I get 16m squared, n to the -13/4, and then p to the 3/2. But because the n is negative, it needs to go to the bottom. So I get 16m squared, p to the 3/2 over n to the 13/4. There we go. There's our answer. Now, the order doesn't matter. You can have m first or p first. Doesn't matter. That does not a big deal. Usually in Canvas, I will probably put the variables in alphabetical order. So if you want to get them right that way, you can, but it really doesn't matter the order in which you do put them in. So let's go on to 17. 17, now this is the distributive property of exponents. Think about that as power to a power. So I'm going to take these, multiply, multiply, and multiply. So on your calculator, you're going to multiply them. Well, -1/2 times 3, 1/2 times 3, and 4/3 times 3. Go ahead and do that now, and then hit play when you got it done. So that's what you get when you multiply them together. Now, because I don't have any other M, P's, or Q's, I just have a single one of them, and this is a negative, and that goes to the bottom. So this is going to be P to the 3/2, Q to the 4 over M to the 3/2. That is your final answer there for 17. That was pretty simple. Let's go to 18. Again, I'm multiplying these together, so multiply, 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 again, multiply, and then hit play. So when I multiply, this is what I get: h to the -3, j to the -2/3, and k to the -1/2. Well, these are all negative exponents, so that means all of them have to go to my denominator. So h to the 3rd, j to the 2/3, and then k to the 1/2. And then now I have nothing up top. Some of you are not going to want to put anything up there. Some of you are going to probably want to put 0. No, you got to put a 1. It is a 1, okay? So that is your answer there for 18. 19, again, let's multiply them together. It's j to the 1st, h, and k. So let's multiply, and let's multiply. Again, calculate it. So that's what I get when I multiply. The h is the only thing that's negative, so that goes to the bottom. So I get j to the 1/3, k to the 1/6 over h to the 2/3. That is your answer for 19. Let's go to 20. Again, multiply powers, multiply, multiply, multiply. Hit, and then do it and hit play. So that's what I get when I multiply. I get m to the -2, p to the -21/8, and q to the -3/4. Again, these are all negative, so I got to put them in my denominator. So I get m squared, I get p to the 21/8, now it's positive, and then q to the 3/4. And then hopefully remember right from 18 that we have a 1 up top. All right, that's it. Let's go on to the next page. So on this particular page, this is the last page of your notes. And these problems are going to get a little harder because there's a lot more variables, a lot more exponents with fractions and stuff like that. So you're going to really kind of have to keep track of what you're doing. The first thing you always want to do is to kind of get rid of parentheses. So I know there's no parentheses on 21 and 24, but on 25 there is, 26 and so on. So that's the first thing. Second thing is, let's use the quotient rule. The quotient rule states that if I have a variable to a power over the same variable to a different power, I subtract powers. So m minus n. Remember we talked about if this number was negative, that means it goes to the bottom of my fraction. So it would be a to the whatever. If it was positive, remember, it would go to the top of my fraction and it would stay up top. So we're going to use that knowledge now, using the calculator to subtract, okay, with our variables there, and then we're going to hopefully arrive at a right answer. So let's work on 21 here. So let's work up top. Is there anything I can combine up top? X's, Y's, and Z's, cannot combine those. Denominator, can I combine X's, Y's, and Z's? No, I'm done. So then we have this. This 2 is going to stay there, okay, because there's no number up top that it can simplify with. So that's what we get there. Now, what am I going to do? I'm going to take x to the 5/4, and I'm going to minus it from the other exponent in the bottom. So that's minus 1/4. And again, you can calculate that here in a little bit, and I'll have you guys pause and do that. But then I get y's. I get y to the 3/2 from up top minus 3/2 from the bottom. Well, that's hopefully understandable that that's going to cancel out and not going to be anymore, because this is 0 of them, right? And then what I do is I get z to the 7/4 from the top minus, but now this is a negative, so it's really a minus a negative 1. Don't forget that. Don't just say 7/4 minus 1. It's not minus 1, it's minus a negative 1, okay? Please don't forget this aspect of it. That's going to mess everything up if you do. Now, I want you to put these in calculators. 5/4 minus 1/4, calculator. 7/4 minus negative 1, calculator. All right, so hit pause and hit play and then find out what you get. So that's what we get, right? X to the 4/4 and then z to the 11/4 over 2. But x to the 4/4 is just a 1, so that should be just a number 1. And you don't even have to write that if you don't want to. You can just write it as x times z to the 11/4 over 2. That would be acceptable as well. So it's not really that bad. It's just we got to make sure that we're keeping track of our numbers. Second one, number 22. I can simplify 4 divided by the 2 here. Okay, that's a 2, obviously. Can I combine x's and y's up top? No, and neither in the bottom as well. Now let's subtract our variables that I have, right? So x to the 4/3, remember it's always top minus bottom, but this is minus, again, a negative, so minus a negative 1/3. Okay, I get y up top, but that y up top, there's no other y's in the denominator, and we already know that's negative, so we already know that it's going to be in my denominator. We already know that, so I can just be done with that, and that's kind of done. I'm not dealing with that anymore. Now I have what? Z to the negative 3/2 minus 1/3, or minus a negative 1/3. I'm sorry, I almost forgot that. But it's a negative 1/3, so it's minus a negative. Now let's put in your calculator, find out what we get. So that's what I get when I do the subtraction. 4/3 minus a negative 1/3 is 5/3. Negative 3/2 minus a negative 1/3 is negative 7/6. But again, this is negative, right? It goes to the bottom. So answer 2, x to the 5/3 over y to the 3/4, and then z to the 7/6 power. That's our answer for number 22. All right, let's go to 23 and 24. Let's get those knocked out of the way. Okay, 23, can I multiply and combine anything up top? 2 m's and p's, no. 2 m's and p's on the bottom, no. But I can now simplify the 2 and the 2, so those go away. There is no longer any numbers other than a 1 as a coefficient, right? 2 divided by 2 is 1. Now let's gonna do our variables here. M to the 1/2 minus 4, and then p to the negative 2 minus negative 2/3. So now, again, calculate that, then hit play. So when I calculate the m's and the p's, all this exponent stuff here, I get negative 7/2 for the m and negative 4/3 for the p. So because those are both negative, they got to go to my denominator. So m to the 7/2, p to the 4/3. Again, we talked about it. What's left on top? Nothing, but it's really a 1, right? So there's our answer there. 24. Can I combine anything up top? X, Y's, and Z's? No. X, Y's, and Z's on the bottom? No. But I can reduce 4 and 2. That becomes a 2. So the 2 is left up top. X's, let's get rid of those. So it's x to the negative 5/3 again, minus, and then 3/4 is my denominator one. And then I have y up top with the 3/2 minus negative 1/3, negative 1/3, there we go. And then a z, what's up top? Negative 3/2 minus, and then a 1 on the bottom. So minus 1, that was easy. Now again, calculate what you got there and see what you get and then hit play. So once you do your calculations there, subtraction, this is what you're going to get. Now again, negatives go on the bottom, so x is going to go down, z's got to go down. So here we go. I get 2, then y to the 11/6 power, and then my x's go on the bottom is negative 29/12, but because it goes on the bottom, it's positive 29/12. And then z as well. Z becomes positive 5/2. There you go. That's your answer for number 24. Now 25, 26, 27, 28, those are going to be a little harder because now we got variables with exponents that have like raised to certain powers with parentheses, stuff like that. So again, this is where we're going to have to really keep track of our numbers. All right, so let's go to 25. Okay, there's two trains of thought on with the exponents here. So this exponent is being raised to everything on the inside. So it's the whole fraction, numerator and denominator. So what I would suggest you do is to try to clean this up a little bit. Okay, so let's look at my denominator. If I look here, I have h to the third and h to the 2. Remember, I said I can add the exponents because I'm multiplying. That's what that little dot means. So this really becomes h to the 5th power in the denominator. Then I have k to the 5/4 and k to the negative 5/3. Okay, so k to the 5/4 minus 5/3 or plus a negative 5/3. It really doesn't matter, same thing. And then do I have any more j's? No, I don't. So that j is already -4 as well. Okay, -4. And then up top, again, I have my j, my k, my h to the 3/2. Okay, what I'm going to do is I'm going to simplify my k's in my denominator. All right, so I want you to do that as well. So 5/4 minus 5/3. Okay, do that now. So when I did that subtraction, I get -5/12. All right, now, because all of this is being wrapped around that -2 there, I can really kind of finish what I can inside there. So I can combine all my j's, my k's, and my h's from the top and the bottom, just like I did on the previous 4 examples. Then I can get the -2 going at the end. So that could be the last thing I do, and that's what I'm going to do first. So let's do this. We get j to the 1, that's up top, minus what? -4. So minus a -4. Then I have what? I have a k to the 1 up top, minus what? -5/12, -5/12. Then I also have my h up top. So I have h to the what? 3/2 minus 5. So I'm going to calculate that real quick, and hopefully you do as well. So that is what I get there when I do all my calculations for my j's, k's, and h's. I combine them, I get j to the 5th, k to the 17/12, h to the -7/2. So because that's a negative, I can place that in my denominator. So it's h to the +7/2, and that means that goes away. I'm like a genie with my editing skills. Got some Christina Aguilera, some genie in a bottle playing in the background right now for you. All right, so 7/2, there we go. Now, all this we forgot, hopefully didn't forget, but maybe some of us did, but hopefully we don't, is still raised to the -2 power. What does that mean? That means this gets distributed through, right? So let's do that multiplication and then hit play again. So that's what I get when I multiply the -2 with everything there. And you notice my negatives, everything is negative, so that means everything is going to change positions. So that means my j is now in my denominator, so that's 10 in there. My k becomes -17/6, now it's +17/6 in my denominator. And my h is -7, which goes to my numerator as +7. So there you go. That is your answer for number 25. It's not really hard. The problem is with variables, with exponents, especially with fractional exponents, that's where we're going to have the hiccup on. Okay, I can't wait till we get to number 28. We're going to have a heck of a time there. We're going to like go home and really, really tell our parents, we're like, Mommy, I learned something today. Well, let's go to 26 first because we can't do that without doing 26. All right, 26 basically is kind of the same as 25, but there's a little bit different ways we have to work on this. And the reason is because this parentheses is not over the whole thing. If you notice 25, it's over the whole thing, so that's why I was able to work on the inside first. Now this one is only in the numerator, so that means I have to multiply here, so let's do that. I get x to the 6th power, y to the 8/3 power when I multiply. Again, you should be able to do that quickly in your head, but if not, that's okay. Now in my denominators, do I have anything I can combine? Yes, actually, I have my y's. I have 2 plus 2 is y to the 4th power down there. Z to the 1/4 is still down there, and then x to the 4/3 is still down there. I don't have any other of them down there, so I don't have to combine them with anything. Now I have x's and y's up top, so let's do some subtraction. My z's, I know that they're automatically going to stay in my denominator as 1/4 because there's no more z's up top and it's not negative, so I don't have to flip it. Okay, and then let's do some x's. I got x to the 6th minus what? Minus 4/3 for my denominator. Then y to the 8/3 minus what? Minus 4. Again, use your calculator to calculate the calculation and make sure you calculated it correctly using the calculator. So when I do that, the x's and the y's, I get 14/3 and negative 4/3. But again, the negative 4/3 got to go to the bottom. So x to the 14/3 over. Remember, my z's automatically stayed down there. I didn't touch it, right? So it stayed down there. Y to the negative or to the positive 4/3, right? It becomes positive when it goes to the bottom. There you go, right there, right there. Let's work on 27. Now, in this case, I have a couple things working against me here. Yes, I have a lot of stuff I can combine up top, like I have y's up top I can combine. But because this is in parentheses, I got to get rid of this first because it's not around the whole thing. So I got to get rid of that one first. So let's multiply that together. So I get y to the negative 2/3. That's still there. I get z to the 7/4. That's still there as well. And then when I multiply those, negative and negative is positive, so it's 1/2 over x to the 1/2, z to the 3/2. Now let's combine my y's because I can take this one and add them together. So let's do that using a calculator. Okay, when I do the negative 2/3 plus the 1/2, I get negative 1/6. Again, your calculator will do that for you. And then what do I know? I know that's a negative, so I got to move that to the bottom. So let's do that. So that's y to the 1/6 on the bottom. My x's are also on the bottom as well because I don't have any more x's to deal with. And then my z's, hopefully remember now that I'm going to subtract them. So it's really z to the 7/4 minus 3/2. So it's 7/4 minus 3/2, so that should be a calculator. Whatever you get there will be your numerator there. So when you get that, that's z to the 1/4 power. That is your answer right there. Let's go to 28, and this is going to be a great one. All right, 28. Man, hopefully you tell your parents you maybe learned something here, or you maybe want to go cry in a corner or something like that. I don't know, curl up on a little ball. I don't know, but this one is going to be a crazy one. So on number 25, you notice we did the parentheses first, like what's inside of it first. We broke it down. Here, I'm going to do that as well. Since I have the big parentheses, that means everything on the inside I can do kind of together. But then I have some more parentheses on the top and on the bottom. So I have to get rid of those first. So what I'm going to do is I'm going to multiply those, and then I'm going to multiply this 2 with that one, and that one as well. So that's what I'm going to do first. So after I multiply the negative 2/3 with the top and then the positive 2 with the bottom, I get this, and then this is all being wrapped around 1/3. Okay, so now what I'm going to do is I'm going to combine top if I can, or bottom if I can. If you notice, the only thing is I can combine there are the 4/3 and the 1/3. And if I combine those, that gives me just a 1. So my denominator is really x to the 1, y to the 1, and z to the 8/3. And then my numerator is y to the negative 1/3, and then z to the positive 2/3. And all of that is being wrapped around 1/3. Okay, then what am I going to do? Well, I'm going to now do my subtraction with my y's. So negative 1/3 minus 1, 2/3 minus 8/3. Okay, because I have them on top and bottom. So I'm going to do that first, and then let's see what we get. So once I do the subtraction of my y's, negative 1/3 minus 1, and then 2/3 minus 8/3, this is what I arrive at. I arrive at negative 2/3 of my y's and negative 2 for my z's, all over x, and then all of that raised to the 1/3 power. Okay, so then what am I going to do? Well, yes, you have negatives here, and you can move them down below, and then you can multiply by 1/3, but I'm just going to multiply by 1/3 now, and then I'll move them later. That's not that big of a deal. So I get y to the what? I get negative 2/9. I get z to the negative 2/3, and then I get x to the 1/3. Now I'm going to move my y's down, my z's down, and then I'll have my final answer below. Once I drop the y's down and the z's down, you get this down here. All right, 1 over x to the 1/3, y to the 2/9, and z to the 2/3. All right, there's a you try section. Pause the video, try them yourself, please, without any assistance. If you need help, hit play. You're going to find the answers out anyway, but if you really need help, hit play, please. All right, for number 29, I have a 2 times 1 times 1, really my coefficient, so that's just a 2. My x's, I have a -1 and a +1. They just cancel because it just gives me 0. And then x to the 5/3 will be right there as well. And then my y's, I have y here and a 1/2 there. When I add them, I get y to the 3/2. That is your answer for number 29. That was pretty simple. Number 30, let's multiply. So I get x to the 1/4, y to the what? 3/4. Can't do anything with it. I am done. Those are pretty simple. Only if everything else was that easy, right? 31, can I reduce 3/4? I cannot, so 3/4 has to be there. Now let's find out my v's. I have 2 on top, 2 on the bottom. They're going to cancel. When I subtract, I get 0. Okay. If you haven't known this already, when I do any variable, so a to the 0 power, that just gives me a 1. Always gives me a 1. So v to the 2 minus 2 is really v to the 0, which is just a 1. That's why I can just say, hey, I can cancel them out. And then now I subtract 4/3 minus 1 for the u's. So this is u to the 1/3 up top. So that is my answer, 3u to the 1/3 over 4. Number 32, this is going to get a little bit tricky. I want to do the parentheses first. I want to do the inside. I want to combine stuff inside. So I have an x here and then no x's again, right? So it's x to the -7/4 is going to stay there. Then I have y to the 1/2 and y to the -4/3. I want to combine those, right? So it's y to the 1/2 plus a -4/3, or just a -4/3, doesn't matter. But your calculator will tell you what that is, so you should have already had that. So that's y to the -5/3 when I combine those inside. Now your z's, you get 3/2 plus 4/3, so let's do that real quick. And again, you should have this already. You get z to the 17/6. Now all of that is being raised to the -3 power. So I have to multiply everything by the -3 there. So let's do that. So x to the -7/4 and then to the -3 by basically multiplying them together. That's 21/4. Then I have y to the 5th power, and then I have z to the -17/2 power. And then I still have my x to the 4/3 up top, my y to the 3/2 up top, and my z to the 5/3 up top. That's supposed to be a 5, sorry. So now again, I'm going to subtract like things. So I did x to the 4/3 minus 21/4. I get y to the 3/2 minus 5. And then I get z to the 5/3 minus the -17/2. Don't forget that -17/2. So calculate, you should have had that already calculated. So that's what you get there, but then I have negatives, so then they have to go to my denominator. So what's left on top? I get z to the 61/6 over x to the 47/12 times y to the 7/12, or 7/2. I'm sorry, 7 over 2. That is your answer for 32. That's it, man. This includes this video right there. That's your lesson 6.4, rational exponents. I can tell you right now, this video is over an hour long before I start editing it. I will tell you that this is really not that bad of a section. It is just making sure that you are keeping track of your numbers. Please, please, please ask questions if you have any. But other than that, you should be good to go. So remember, signing out here, take notes, do work, and you will find success.